Okay, so we finished the last one with labeling the x and y axis with radians in terms of pi. Today, so that this piece here is already taken care of. But now we have to do it to the nearest hundredth. So let's recall what pi is equal to. We know pi is equivalent to 3.14, and some of you even know further, but to the nearest hundredth, we can label this 3.14, okay? And you should be comfortable with that. So that means that 180 degrees is the same exact thing as pi radians, or 3.14 radians. Well, half of 3 is going to be somewhere at 1.5, but just over it. So right here is going to be 1.57. And then 3.5, so I would be adding a 1.57. Up over here, you're going to get approximately 4.71. 4.71. And then here, this is 2 pi, it's 3.14 plus 3.14, so that's roughly a 6.28. So those are values that really you should get comfortable with, and obviously, you know, the starting point, I should have said it's 0, then goes to 1.57, then to 3.14 radians, 4.71 radians, and then 6.28 radians. So that's important for you to get comfortable with, and you'll need that for the homework. Okay, moving on, we're going to talk about converting degrees to radians. This is something that you did last year. So we need to always just reference the fact that we know that 180 degrees is equal to pi radians. So if I go ahead and I ask you, all right, let's convert 30 degrees to radians. So there's one piece where you might have known from chemistry called stoichiometry, or algebra, where we've referred to this as dimensional analysis, is that if you have degree on top, you want the degree on the bottom so that it cancels out. But what's the conversion? The conversion is there's 180 degrees to pi radians. So that means that 180 is going to go down here and pi will go up top. So this is just over 1, and you can just multiply numerator times numerator, denominator times denominator. So I get 30 pi over 180. So now, sorry, I'm just going to warn my kids that I'm recording. All right, so I have 30 pi over 180, and now you want to reduce it. So when you go to reduce this, you're going to get that these zeros cross out, and this 3 goes into itself once and this into it 6 times. So I reduce simplified version, get pi over 6. So 30 degrees is equivalent to pi over 6 radians. And that's important value that you should remember moving forward. Now, if I want to convert radians to degrees, you're going to just work backwards. So say I have pi over 4, and I go, well, what is that in degrees? I want to times it by, now on top here, I want radians to go away. All right, this is pi over 4 radians. So I want radians on the bottom. We know that's pi radians, and I want 180 degrees to be on top. That is my conversion. So when I go ahead and multiply this across, I get 180 pi over 4 pi. And yes, the pi's cross out, and you end up reducing this to 45 degrees. So pi over 4 radians is equal to 45 degrees. Guys, you could cross-reduce before, like here, I could have just cross-reduced here and said 30 goes into itself once and 30 goes into 186, but you just need to know that if you're multiplying fractions, it's numerator times numerator, denominator times denominator. I don't want anyone cross-multiplying. So that's the way that we most generally reduce and change to degrees to radians and radians to degrees, is we just look at the conversion. We say, like, if I'm trying to take 120 degrees and I want to get rid of degrees and change it to radians, you're just going to go, okay, I want the radians on top and the degrees on the bottom. So that's the conversion that you use. And so those degrees cross out and you get 120 pi over 180. And again, you would just reduce, and you would see that 6 goes into both, so you get 2 pi over 3. That's one way. There is another way that we will show you in class, which is a proportion, but this is the way that I think that most kids are most comfortable with. If you recalled something with proportions, we will show you that method next time in class. Okay, now to just move on, because I don't want to keep you forever online. Multiples of 30, we just said that 30 degrees was pi over 6 radians. So let's just think about what that looks like graphically. I know that if I'm dealing with radians, no longer with degrees, if I'm dealing with radians, I know that for sure 180 degrees is equivalent to pi radians. So I know that that is pi. And pi over 6 means that I took pi and I divided it in 6. So 6 spots. So think about this. If I have this is pi radians, and if I want to divide it in 6, from here to here, I want 6 slices, then I'm going to have 1, 2, 3, do the 3, that's on the black line, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6. I just took pi and divided it in 6. So that means that one of these slivers, okay, so right here, this angle that I just labeled 1, that's pi over 6 radians. That's a 30-degree angle, and we know that a 30-degree angle is acute, okay? If I have a 30-degree angle and I come all the way up to this angle, that means I have 5 30-degree angles. 5 30-degree angles tells me I'm at 150 degrees, right? Well, guess what? 150 degrees is 5 pi's over 6. So if I went ahead and did the whole conversion method, you would see it's 5 pi over 6. Why am I showing you this? Because you should be able to visualize what pi over 6 is and how to graph it. So that being said, if I went ahead and said, I want, and I'm going to talk about multiples of 45 in a second, but if I wanted to graph the radian angle, okay, in radians, something called 3 pi over 4. Okay, I'll say, all right, let's see. If I want to graph that, I want to just look at this angle as the fact that I took pi and divided it in 4 sections. So let's take pi, remember this is pi here, and if I divide it in 4 sections from the start to the finish, that means I'm going to have 1, 2, 3, 4 sections, correct? So that's pi being divided. And I said I want 3 of them. So the angle that I'm actually drawing here is up to 3. And then my terminal side, that's in the second quadrant. Now you're going to see that we have special values such as pi over 3, pi over 6, and pi over 4. We just said before in this slide that pi over 4 is equivalent to 45 degrees. So if I know that this is pi over 4 and I have 3 of them, well, I just multiply 3 times 45 degrees. This angle is 135 degrees. All right, so this is stuff that you want to get comfortable with, and we'll have plenty of practice together. So right now you should be printing out that worksheet, and I'm going to do a type of each lesson, each type of problem off the homework with you, and it might fall into yet another video. I apologize. So here it says estimate the angle to the nearest 1/2 radian. They want the measure in radians. So first of all, I know that vertex, I'm going to look at it as being on the x and the y-axis, and this is in standard position, so this angle starting at 0 and it's going all the way around. It's definitely going beyond pi. So I want it to the nearest 1/2. So I'm going to work with the decimal version of what we came up with radians. So we said this was 0. We said that this was 3.14. We said that this was 1.57 up top, and this was roughly 4.71. So if I look at, and over here is 6.28, right, as another value. So this is in the third quadrant. I've gone a full semicircle and way more, past 270 degrees, so past the 3 pi over 2 or 4.71 radians, and I'm trying to round it to the nearest half. So if I look at this, I would say that this is approximately 5 radians. Okay, I would say that this is approximately 5 radians. If you went 5.5, you could have an argument, but obviously it wouldn't be 6 because it's not very close to this 6. Right, so that's what this section, when you have to do, you're going to have to do number 4 and 6 on that, is what it's asking. All right, for number 10, this follows the same suit as number 11 for homework. It says determine the quadrant in which each angle lies in. So again, they are telling me the angle that they're giving it to me is in radians. So here I go, oh, -1. So -1, I know that this is a whole number. I want to think about it in terms of the decimals, right? So 0, this is 3.14, this is 1.57, this is 4.71, and this is 6.28. However, I see that it's negative. So you want to just think about those same values, but in the opposite direction. This is 0. This is negative 1.57. This is negative 3.14. This is negative 4.71, and now this is negative 6.28. So where is -1? It's going to fall between 0 and negative 1.57. So this -1 angle in radians is going to land in the fourth quadrant. So 10A would be the fourth quadrant. Here, they're giving me in terms of pi. So again, I'm looking, and it's a negative rotation again. So I'm going to look at this and say, okay, this is a little, I got to take pi and divide it in 9 slices. So way more than we've done before, but that's okay. So 9, I can't do 4 and 4. That would just give me 8 in each section. So I'm going to go a little bit more than 4. So it's going to look something like this. 1, 2, 3. We're going to get a 4th in there. Our 5th is going to be in between, so that's 5. So far I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but I want to go 11, so I got to go more. So I want to think, okay, each quadrant is containing 4 and a little bit more, right? So if I want to get to to 11, I'm definitely going to have 11 in here because here's 10 and here's 11, and I could continue this to 18, but no need. I've gotten my answer. I'm in the second quadrant. This is negative 11 pi over 9. Okay, moving on. It says sketch each angle in standard position. Standard position means that you're starting from 0. So here, this is still practicing the same idea. You're going to have pi, and you're dividing in a section of 4, and it's negative rotation. So you're taking pi, which is right here, and I'm dividing it in 4 sections. So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. That's going to give me the 2 pi. And I want 7 of them in a clockwise rotation, so there it is. I just sketched it in standard position. You see the initial side and the terminal side is where that arrow ends. Okay, B is positive, and I'm taking pi and dividing it by 2. Okay, well, that's kind of already done for us. This is pi. This is pi over 2, right? So it's being divided in 2. This is 3 pi over 2. And this is 2 pi. And so this is 1 and 2, 3 and 4. And think I want to be at 5. So to get to 5, I have to go a full circle and another 1. So I land here. This would be 5 pi over 2. All right, that's going to end this one, and I'll do